of this lecture is I will see new matrix, block diagonal matrix. This is not easy. Actually, this is nice matrix. This is actually partition in the entries of large matrix. Today I will see this matrix. Actually, block diagonal matrix is sometimes divide a matrix into pieces or submatrices by using system of vertical and horizontal lines in the matrix, and these submatrices are called as a block. As for example, notice this matrix and just partition this matrix, and notice here 2 cross 2 matrix, and here also another 2 cross 2 matrix, and here only null matrix. If you can partition this matrix, then you will easily understand what would be the characteristic polynomial, minimal polynomial, trace, determinant, other properties of this matrix. And here one block and here another block. Consider this block as a 2 cross 2 matrix and consider this block another 2 cross 2 matrix, and here just null matrix. Today I will say this type of matrix, how we will partition this type of very large matrix, how we will see the minimal polynomial, trace, determinant, characteristic polynomial of block diagonal matrix. Have you understood? Okay. This is our actual goal of today's lecture, because block diagonal matrix is actually very important for any competitive exam. But at first I will see one nice example about linear algebra which had come in GATE exam. The question is, given n cross n matrices A and B with entries complex number, and consider the following statement. Option 1, if A and B are same minimal polynomial, then A is similar to B. Option 2, if A has n distinct eigenvalues, then there exists vector u belongs to Cn such that u comma au up to this would be continue, and here since this is started from u, then this would be a to the power n minus 1 u is linearly independent. Then which of the following statement are true? Option 1, both P and Q. Option 2, only P. Option 3, only Q. And option 4, neither P and Q. Which option are true option? Just verify. This is very basic question. First, if A and B have same minimal polynomial, then A is similar to B. We all of us know the properties of similar matrices. We all of us know when two matrices be similar, then their minimal polynomial, characteristic polynomial, rank, every properties are same. But here has indicated the opposite way. Here has given if their minimal polynomial same, then these are similar. This is not, because as for example, consider two matrices. Consider these two matrices and do partition these two matrices. Have you understood this partition? This is one matrix, this is null matrix, this is null matrix, and this is also null matrix. And here the minimal polynomial is x square. Now partition this matrix, B matrix. Here notice, here this block and here this block, and minimal polynomial also would be x square, and because this is the null matrix. So for this block, both minimal polynomial are same. but these two matrices A and B are not similar to each other. That means by definition there does not exist any invertible matrix P such that A equal to P inverse BP. That means A does not similar to B. Have you understood this definition? Well, these two matrices are not similar because we all of us know for similar matrices their minimal polynomial same, their characteristic polynomial same, determinant same, rank same, all properties are same. But here in the matrix A, rank is 1, but in the matrix B, rank is 2. So actually these two matrices are not similar to each other, but their minimal polynomial are same. Notice, for these two matrices, minimal polynomial both are same, but these two matrices are not similar to each other. That means if minimal polynomial are same, that does not imply these two matrices similar. But when two matrices will be similar, then always minimal polynomial would be same, but converse not to. Have you understood? Okay. And option 2 imply if A has n distinct eigenvalue, then there exists U belongs to Cn such that U comma AU up to a to the power n minus u is linearly independent. To prove actually, given A is n distinct eigenvalue, we have to prove these are linearly independent. For this, since A has given n distinct eigenvalue, so obviously the matrix A is diagonalizable. That means since matrix A is diagonalizable, that means there exists n linearly independent eigenvector, and these eigenvectors are nothing but, this is actually the basis of Cn. Consider this basis which contain this eigenvector u1, u2 up to un which are eigenvector of Cn. Okay? Then now consider any factor u of Cn which we can write as alpha 1 u1 plus alpha 2 u2 up to alpha n un. Okay? Now multiply this equation by A. Then this would be AU equal to alpha 1 AU1, and AU1 means actually lambda u1. That means this is actually lambda 1 u1 plus alpha 2 AU2, and AU2 means actually lambda 2 u2. Okay, and this would be continue here alpha n. AUN means lambda n un. Okay, this is the AU. Here we have to find this set be linearly independent. For this, notice here the scalar would be for u alpha 1, alpha 2 up to alpha n, and for AU here the scalar alpha 1 lambda 1, alpha 2 lambda 2 up to alpha n lambda n. Okay. Similarly, this would be continue a to the power n minus 1 u. For this, the scalar would be such type alpha 1 lambda 1 to the power n minus 1, alpha 2 lambda 2 to the power n minus 1 up to alpha n lambda n to the power n minus 1. Okay, and for this coefficient the determinant would be such type determinant here alpha 1, alpha 2, alpha n. Here for AU the coefficient since this part, so this is the second column, and for a to the power n minus 1 u, since the coefficient would be such type, so this is the n minus 1 column, and just common alpha 1 from first row and common alpha 2 from second row, and similarly common alpha n from last row, then this would be 1 lambda 1 up to lambda 1 to the power n minus 1. Here would be 1 lambda 2 up to lambda 2 to the power n minus 1, and this would be continue. Here would be 1 lambda n to the power n minus 1, and this determinant is nice determinant. Here notice, since lambda 1, lambda 2, lambda n be the distinct eigenvalue, that means obviously these values are all distinct, so this determinant would be 0, and since determinant is not equal to 0, that means obviously u up to a to the power n minus 1 u are linearly independent. Have you understood? Option 1 is a wrong option and option 2 is the right option. Okay? Here would be P and here would be Q. So only Q would be true and P is wrong option. Have you understood this question? This is very basic question, just conceptual. Okay, the main goal of this lecture, block matrix. At first I will see various type of block matrix. At first I will say what is the block diagonal matrix. Then I will see block upper triangular matrix, block lower triangular matrix, etc. Now I will see block diagonal matrix. A block square matrix is said to be block diagonal if all non-diagonal blocks are 0. Just partition this matrix. Here notice, in diagonal these blocks are non-zero, but in the off diagonal these blocks are actually 0 blocks. So this is the block diagonal matrix. Have you understood? Okay. Now I will see what is the block upper triangular and block lower triangular matrix. A block matrix is said to be block upper triangular if all the block below the diagonal is 0. This is the block upper triangular matrix. Okay. And the block lower triangular matrix would be such type. A block matrix is said to be block lower triangular if all the blocks of above the diagonal are 0 matrix, and this is the block lower triangular matrix. Here notice, all the block above the diagonal is 0 matrix. Here this is the block upper triangular matrix. Notice here all the block below the diagonal is 0 matrix. Have you understood this block matrix? Now I will say some properties of block matrix. At first I will see determinant of block diagonal matrix. Here notice this is the block diagonal matrix. Then determinant of the matrix is denoted, since this matrix is denoted as P, determinant of this matrix is determinant of A times determinant of B. Similarly, consider Q is block upper triangular matrix, but determinant of this matrix is, here B not be included on determinant. Similar to block diagonal matrix, this would be determinant of A times determinant of D. Similarly, block lower triangular matrix, determinant is determinant of A times determinant of D. Here C not be depend on determinant. Okay, this is the determinant of block diagonal matrix. Now I will say another properties of block matrix. Okay, I will say characteristic polynomial of block matrix. At first I will say this is the block upper triangular matrix. And here the characteristic polynomial means ti minus determinant of ti minus a. This is the characteristic polynomial, which would be determinant of ti minus ai b 0 determinant of ti minus a2, and this determinant actually ti minus ai times ti minus a2, and this is nothing but this is actually characteristic polynomial of a1 times characteristic polynomial of a2. That means the characteristic polynomial of block matrix, if block matrix be upper triangular, lower triangular or block diagonal matrix, then this would be such type. Let A be block triangular matrix with block A11, A22 up to ANN, and consider Cix be the characteristic polynomial of Aii. Then characteristic polynomial of A is equal to C1 times C2x up to Cnx. That means this is actually characteristic polynomial of A11, characteristic polynomial of A22 up to characteristic polynomial of ANN. Have you understood? Notice this matrix. Here 5 cross 5 matrix. Now just partition this matrix as such type. Notice here this matrix is such type A, here 0 matrix, here 0 matrix, and here B. This is the B matrix and this is A matrix. Actually this is the block diagonal matrix. Then my question, what is the characteristic polynomial of this matrix M? This is actually characteristic polynomial of A and characteristic polynomial of B. Characteristic polynomial of A, just calculate, this is actually would be x square minus 4x plus 3, which is equal to x minus 1 times x minus 3. And characteristic polynomial of B would be x cube minus 3x minus 2, which is actually equal to x plus 1 whole square times x minus 2. That means characteristic polynomial of this matrix M is x minus 1 times x minus 3 times x plus 1 whole square times x minus 2. This is the characteristic polynomial of the matrix M. Have you understood the method? If block diagonal or block upper triangular or block lower triangular, always characteristic polynomial would be equal of characteristic polynomial of every diagonal matrix. Okay? I hope my all viewers have understood how we have to find the characteristic polynomial of block matrix. Now I will see the minimal polynomial of block diagonal matrix. Suppose M is a block diagonal matrix with A1, A2 up to AN as a diagonal block, and consider M is such type where A1, A2, AN as a diagonal block, then minimal polynomial of this matrix is actually the minimal polynomial and characteristic polynomial of block matrix are both different, because minimal polynomial of this matrix would be LCM of A1, A2 up to AN. That means actually the minimal polynomial is multiple of both A1, A2, AN. Okay? This is the minimal polynomial of any matrix. Have you understood how we have to find the minimal polynomial of any matrix? Okay. Now I will say what is the minimal polynomial of this matrix. Okay. See, this is the characteristic polynomial of this matrix, but minimal polynomial is LCM of minimal polynomial of A and minimal polynomial of this B. And here for A, since the characteristic polynomial is linear factor, so this is also minimal polynomial of A, but for this matrix B, since the characteristic polynomial is x plus 1 whole square times x minus 2, then minimal polynomial would be x plus 1 times x minus 2. Just calculate, because a plus identity times a minus 2i would be 0 operator. So minimal polynomial of this matrix would be LCM of minimal polynomial of this matrix. Okay, I have got the minimal polynomial of this matrix is x minus 1 times x minus 3, and minimal polynomial is this matrix is x plus 1 times x minus 2. Then their LCM would be x minus 1 times x minus 3, x plus 1 times x minus 2. Have you understood? This type of property actually very important for any competitive exam. If you know this property, then you can verify any question of block matrix. Now I will say what is the trace of block matrix. Till now I have seen characteristic polynomial of this any block diagonal matrix would be, if the matrix is such type, then this would be characteristic polynomial of A times characteristic polynomial of B. Similarly, determinant would be determinant of A times determinant of B. Also I have seen minimal polynomial of this matrix is LCM of MAX, MAB. Then what would be the trace? Trace would be trace of this matrix A plus trace of this matrix B. Okay, and this type of property actually very important. Today I will stop here. In my next video I will discuss some question about this topic. But at first I will highly recommend you, please see today's video with pay attention, because if you know this property in proper way, then you can easily verify this type of question. Okay, see you soon. Stay safe and stay positive always. And don't forget to subscribe for more videos of my channel. Thank you so much.